name is Will Groves, and I'm here to share a dynamic scheduling model that was created for a snack foods manufacturer. I'm a senior consultant at Argon Co, where I work across our analytics team, as well as delivering manufacturing and operational excellence improvement projects. During my time at Argon, I've been involved in creating digital twins for a wide range of clients and use cases, including scenario modeling for manufacturing site design, bespoke scheduling models, and even store design and layout for fast food restaurants. We've been using Simio for our digital twins because it gives us the flexibility to model any combination of processes in an easy-to-use interface, especially helpful when we hand models over to our clients. And having complete control over the simulation also ensures that we can focus on what's important and simplify where additional details and complexity aren't required. Before jumping into the rest of the presentation, I'd just like to quickly thank the team from Simio for inviting Argon Co here to present at SimioSync, and to yourselves for joining. So this scheduling model was built for a client who's a major producer of snacking products in the Australian market. They've got multiple types of products, such as potato chips, corn chips, and then others which are extruded or blown from a pellet. Products generally come in larger share bags, as well as smaller lunchbox sizes called inners that are sold as multi-packs. They previously had 2 manufacturing sites in Sydney. However, they've recently completed the build of a new state-of-the-art factory intended to replace the original 2 sites. The new site's now live, with volume being transitioned over throughout this year. We've got a long relationship with this client, working with them across a wide range of projects. We are trusted by the client to deliver complex transformation programs, including delivering operational excellence projects, scenario modeling and design of the greenfield site, leading the project management of the recent successful commissioning and vertical startup of that site, along with detailed capacity modelling of their new automated warehouse using Simio and labour planning process improvements. The main aim of the project was to improve the client's planning and scheduling processes. Previously, all the scheduling was done, as is quite common, in an Excel spreadsheet. This led to numerous challenges for the client, and there was a clear opportunity for improvement with a dynamic and intelligent scheduling solution. In particular, the site's quite complex, with multiple shared assets such as fryers and seasoning drums. Most basic scheduling tools struggle to handle shared assets and complex interactions across a factory, and as the previous tool was not integrated well into the wider business, it was a slow and manual process whenever the plan needed to be changed. Following on from the challenges of a complex site, this led to the true capacity not being well understood, especially with varying product mix. We'll get more into the details later, but one example of this is there is a delicate balance between small and large bags. And to make it even more complicated, consumers are constantly looking for new products and flavours, so the snacking industry has a rapid innovation cycle. The impact of this on the site was difficult to calculate. Finally, planning was siloed and the site struggled to align between ops, maintenance and the planners. This meant that it was hard to minimise disruption from engineering shutdowns and balance this with operational requirements, all while maintaining high customer service levels. The main aim of the project was to improve the client's planning and scheduling processes. Previously, all the scheduling was done, as is quite common, in an Excel spreadsheet. This led to numerous challenges for the client, and there was a clear opportunity for improvement with a dynamic and intelligent scheduling solution. In particular, the site is complex with multiple shared assets like fryers and seasoning drums, which most basic scheduling tools struggle to handle. As the previous tool was also not integrated well into the wider business, it was a slow and manual process whenever the plan needed to be changed. The complexity of the factory led to the true capacity not being well understood, especially with varying product mix. We'll get more into the details later, but one example of this is there needs to be a delicate balance between small and large bags. And to make it even more complicated, consumers are constantly looking for new products and flavours, so the snacking industry has a rapid innovation cycle. The impact of this on the site was difficult to calculate. Finally, planning was siloed and the site struggled to align between ops, maintenance and the planners. This meant that it was hard to minimise disruption from engineering shutdowns and balance these with operational requirements, all while maintaining high customer service levels. To address these issues, We developed a scheduling model in Simio for the two sites. The tool would be integrated into their ERP to automate data inputs where possible and ensure that the model is receiving an accurate picture of the plant. Once the model was built, validated, and integrated into the renewed planning process, we were asked to extend the model to include the new site, at the time no more than an empty field. We used this model for scenario testing for the new site, providing useful insights and informing asset selection, which ultimately fed into the site layout and final build. Now that the new plant is up and running, the Simio model is scheduling for all three factories in the same model, supporting the volume transition and shutdown of the old sites. The planning team were all trained by us in Simio and can easily manipulate the plan, changing sequences, volumes, production routes, and anything else. The Simio model is quick and easy to use, allowing the team to spend more time on strategic decision making and long-term planning, instead of taking time manually updating a spreadsheet. And to ensure that all stakeholders had visibility of the schedule, we set up the Simio output tables to feed into their ops and production dashboards. The plans visible on tablets and screens around the factory, also linking to the daily, weekly and monthly reviews where attainment, plan adherence and other operational KPIs are tracked. Now let's look at the design of the model. Starting with a simplified process map of just a small part of the factory, we can see on the left that raw potatoes come into site and are washed. They're then sliced before being sent to the fryers. Once coming out of the fryers, they need to have their flavour added before being bagged. Some baggers have their own seasoning drums on each bagger so they can run independent flavours, whereas others down the bottom have a combined seasoning drum feeding multiple baggers. This then locks those two baggers onto the same flavour, but not necessarily the same final product. We can see that we've got two different types of baggers here, inners baggers and large baggers. Inners are the packs which end up going into other multi-packs, generally for lunch boxes, and the large baggers are your sharing packs and party packs. The inners are transferred on inner highways, which are just conveyor belts, into their whip storage before going to secondary packaging, and the large baggers go straight to case packers before ending up in the finished good warehouse. We can see here that those first two baggers go onto the same inner highway, so therefore they have to be making the same product, whereas those next set of two, they can be making an entirely different product. The baggers either have their own case packer or will have shared case packers. Obviously with the case of shared case packers, they have to be running the same product. Final consideration is that when we're running fryers, obviously they're only set to one different type of potato cut at the same time, so we're either making thin cut or crinkle cut. We can't do a bit of each. We decided to only model the frying to the inner highways and case packers because that was the bit of the factory that needed scheduling. We could assume that there was always sufficient volume coming into the site and that the warehouse would always be able to keep up with whatever production was pushing out. Now looking at the data flows. So the model's integrated into their ERP, with key Simio data also maintained in a bound Excel file. So the SQL database in ERP gives us the SKU master, demand, and BOMs. That's then fed into an input data spreadsheet with Power Query, where we added the asset list, factory setup, like fryer and bagger links, seasoning bagger links, effectively all the routes that packs can take through the factory. Once we've got all that data in Excel, it's then imported into Simio automatically, and then Simio runs the plan and schedule. So that simulates running everything that's in the demand. Routes in the model are automatically created in the Excel file, and the schedule is manipulated inside Simio by the planners. On the output side, once Simio runs, it generates output tables and resource logs and other custom tables we've built, and they then feed into both Power BI production dashboards, as well as being written into the client's SQL database. So now onto the scheduling logic. So the first step is sequencing with cut. So throughout the week, we have a fixed sequence of types of chips to be made at a time, starting with French fries, moving into thin cut, and then crinkle. This sequence is fixed based on this operational preference and factory efficiency. The reason we start with cut dive is because changing the fryer is about a 4-hour changeover, so we really don't want to be doing that more often than we need to. After that, we run through a sequence of flavors, starting with our light flavors, so salts, and ending with our heaviest flavors, such as barbecue and chili. Again, reasoning for this is to ensure that we have reduced changeovers. Going down the flavor group is easier. It's easier to add flavors than take them away from cleaning. The next consideration is the fryer drawer and large bags versus inner bags. So each fryer has its own output capacity, and the golden rule is that the fryers always want to be running at the same rate. We can't slow them down, we can't speed them up. To be able to cover for breakdowns, we've got to make sure that the total bagger draw, or the total requirements by kilos of potato chips going into the baggers, is higher than what the fryer is capable of putting out. This is because if there is a breakdown, the product can't be sat out on the conveyor belts, otherwise it'd go stale very quickly. This then leads to the final bit of complexity, with that balance between inners and large bags. We've got to make sure that any time inner baggers are running, we've got to have large bags running at the same time. The reason for this is the inner bags with a small pack don't draw many kilos per hour from the fryer. Because we can't slow the fryer down, we've got to make sure we've got enough large bags to draw the volume to keep the fryer happy. Now looking at how we built this in Simio. So the source is linked to the demand table, where orders were released for the week. There's a node for each stream, potato, hard bite, corn, and a few others, and orders queue at each of these nodes, waiting for Simio to allocate them to a bagger. The allocation's based on the scheduling rules from before, such as checking what the current flavor that the bag is making is, and ensuring that the next one it does is further down the list of light to dark. Each bag is modeled as a server. They seize their relevant resources, so that's the fryers, the seasoning drums, case packers, inner highways on entry, and each server's linked to a flow asset. So we use flow in this model to continuously calculate the bagger draw on the fryers, and the flow regulators are controlled by the linked servers. So when order's released from the demand table, queues at its node until a bag is free, goes to an appropriate bagger, seizes the resources it needs, and then opens the flow regulator, which then calculates how much flow or how much potato is being placed at each bagger. Once the order's done, the flow regulator shuts off, the order moves on from the server to the sink, and the output tables are updated. Now we'll go looking into the Simio model itself. So now we're inside Simio, let's have a look around at the model and the data before jumping into how it works. So up the top, we've got the two old sites, and down the bottom, this OH section is the new extension. The logic is the same across all three sites, so we'll just focus on the bottom bit for now. We can see we've got process maps on the floor for each stream, so potato, hard bite, which is just another different type of potato, corn, and then cereal, MPF, and pellets, which are just additional product streams. We've got the fryers on the left there, and then next along the servers representing all the baggers. We've got case packers modelled as resources only where we need them, i.e. when they're shared. When it's just a single case packer to a bagger, no point adding extra complexity. The linked flow sources and sinks are up here. We've got a fryer being modelled as a flow source, and each bagger is linked to its own sink. These routes are then effectively all the different ways of the chip being able to be produced through the factory. So orders come in from the source demand up there, and then they'll queue up at the required node for each stream before making their way through the model. So if we look into the streams in detail, we've got potato. This is just our regular potato chips. We've got one big fry putting out 3,000 kilos an hour, and then this second one here, which was an option. And we've got a big bank of twin head baggers, and then a big bank of single baggers, which are the large baggers. These ones go into the case packers, the twin heads go onto those inner highways. We can see here that these inner highways, the first 3 baggers are on the same inner highway, the second set of 3 are on their own, so that forces us to only be able to make 2 different products at the same time for small bags. With large bags, we can do anything we like. Each one's got its own case packer. Similar story with hard bite. We've got 2 fryers that are actually locked and have to run the same cut at the same time because they both feed the same bank of baggers. This means that we've actually just decided to model it as one fryer on its own for simplicity. We've got the last fryer here, UPC4, has its own bank of baggers, but you'll notice it can't make any small bags. These are all large baggers. We've got an additional asset here, UPC3, which was again just for scenario modeling. Where we've got the case packers being shared, we've got the shared resource. Other than that, they're all the same. Corn, we've got 2 fryers going into 3 drums, seasoning drums. Each seasoning drum has its own bank of baggers. This means that the baggers have to be running the same cut and the same flavour at the same time. The only thing we can vary here is the pack size. You'll notice here though that these 2 twin heads are going onto the same inner highway, so therefore we have to be making the same product at the same time on those 2. And down the bottom here, a similar situation where the last 2 baggers actually share a case packer, so they have to be making the same product. Finally, the smaller lines, we've got cereal, MPF and pellet. There's different streams. They each have their own fryer and each seasoning drum. It's a different technology and product type. And then they have shared banks of baggers. So the first 2 will have all these baggers up here able to be accessed, and the second 2 have these baggers. Some of them have case packers. Bib is just bag in box. It's those boxed pack of chips really. And then we've got the twin heads as well, which need to use the inner highways to get to the whip packing. Okay, so for the data, we've got a SKU master and the demand. Routes is really the power of the model. So this is created in Power Query, and it's a table of every single path that every single different product can make its way through the factory. So we've got SKU, fryer and bagger, flavor drum, and everything else we need. Just get that. Yeah. We've got a table of assets so that we can easily add new assets and move things around, and then a bunch of other tables we need. So initial conditions, this lets us actually set up what the factory is currently doing if we were picking this model up, not on a Monday morning, but a Wednesday afternoon, say. A few other tables we don't need to look at too much in detail. Over on the right-hand side, flow routes. This is a similar thing to these other routes. It's just all those different flow routes between the fryers and the baggers, and their selection weight, all generated in Power Query. This is how we actually control those flow regulators opening and closing. Now let's have a look at how the model works. So once the orders are released from the demand table and start queuing up at the nodes, we have to assign them to baggers. The key part of the scheduling model is obviously this assignment of baggers, which order to send to which bagger at what time. This is controlled mainly through the selection expression and selection condition. So selection expression is just sending orders of a particular size to baggers which have preferences for large bags over small bags, for example. And then the selection condition is what everything that has to be true before the bagger can be allocated. A lot in here we don't need to look too much into. The key ones down here are the fryer cut, here, var cut, is the same as the production group on the SKU master. So each product has a particular type of cut, be it thin, crinkle, lots of others, and the fryer at the time has a variable which matches that. That way we're forcing each fryer to only be making one type of cut at the same time. We've also got things like the flavor drums. So either it doesn't need a flavor drum, i.e. it's going to a bagger which has its own seasoning on the bagger itself, or the flavor on the flavor drum is the same as the flavor for the actual product in the SKU master. That way, a flavor drum's already making salt and vinegar, for example. We can keep adding more and more salt and vinegar chips to these orders, that's not a problem, but we're prevented from adding a different type of flavor. They're really the key things. There's a few others, like overdraw, which I'll talk about now. So overdraw is effectively that almost buffer between what the fryer is capable of putting out and what all the baggers are capable of drawing if they're running at max rate. So the fryer, for example, here is capable of doing 3,000 kilos an hour. All these bags together, based on what pack size they're running, need to be able to pull more than 3,000, and the overdraw is effectively that multiplier. So we've got an overdraw of 2, then all of our baggers combined would be pulling 6,000 kilos an hour, giving us twice as much as what the fryer needs to be. We're looking to have a sufficient overdraw, but not making it too high. We wouldn't want an overdraw of 4 or 5, because then each bagger itself is only running at 20 to 30% utilization. We can control this max overdraw over here with all of these by stream. Their default set to 2, and then BLK cat is set to 3, purely from operational reasons. So once the orders come in and meet the selection conditions, they're then allocated to baggers. When the order reaches the bagger, it begins a bagging process which checks for any required changeovers and therefore time delays, before opening the flow regulator and the linked pipe and beginning production. As the fryer produces product, the order is continually tracking the actual flow through to the bagger, which is impacted by what all the other baggers are doing. When the required volumes are reached, the flow regulator shuts off and the order leaves the bagger. It writes some details to a couple of output tables before moving to the order sink. So now let's have a look at scheduling with this model. So after running the model and moving across to results, we can see the Gantt chart where all the different streams, the fryers, the flavor drums, and the baggers are listed, and we can see what all the different orders that they're doing at any time. Up the top we've got cereal, then we've got corn, hard bite, MPF pellets, potato finally. The colours just signify the flavours, so we can easily see if we're going in an optimal flavour sequence of light to dark. Okay, so now let's find something to change. So we've got multiple different ways of changing things based on what we're trying to do. Simio RPS lets us drag and drop between different lines, so I could say I don't like this order sitting on E21, for example, let's move it to E22. Other options, we can push and pull orders in front of each other. So we could perhaps start with saying, well, actually, I don't like the unsalted going before the salted. Let's do it the other way around. And I'll pull that one backwards. Okay. Now, when you do this, just got to make sure to kill that row that says the order has to follow itself. And I only need one prior usage of that. Now, if I rerun the model, we should see that change. So 5014 is now coming before 5012, the unsalted. That's some pretty easy manipulation that Simio lets us do. We've got lots more complex things we might need to do. For example, we might not want to only be able to allocate one product to one particular line. What if the bagger hasn't got enough time on its own to make the entire order, as is the case with a lot of our high volume products? What if we want to just reserve 2 or 3 baggers for it? So one way we can do that is in the data tables we've built. So we've got these forced routings. This forces a particular product. We can select anything we like. Let's say that one, and we can put it and force onto any bagger we want. That will then ensure that that product only runs there. We can add multiple different baggers for the same product here, and that's how we ensure that we can reserve 2 or 3 baggers for the same product. So I could have 4613 each time, and I can instead now put it on bagger 2 as well, say. That would then show that SKU running in parallel on those 2 baggers. If we want to just take a bagger out of the list of options, we've got on the routes table an ignore step here. So we could find the particular route we want to get rid of and say, no, that order isn't allowed to run on this particular bagger. That could be from operational reasons. So for example, the cleaning or the seasoning drum might have an issue. We might not actually be able to make, say, this has happened before, chili flavor on one particular bagger. That's really easy to do. We can just navigate to the chili flavored SKU and then check ignore. And that would then prevent that order from going on that bagger and therefore making something else go there. So we've got a few different ways. Dragging and dropping lets us allocate one order to one particular bagger. Ignoring is good for when we want to take one or more baggers out the equation, but still let Simio choose where to send it. And then forced routings is where we want to be able to allocate the same SKU to multiple different baggers, and that's something that the drag and drop doesn't give us. So in this way, the schedulers have a lot of flexibility to make the edits they want to do, and at the end of the day, the result is a plan which is not only optimal, but actually achievable for the plant itself. So now let's have a go at manipulating some of the plan. Something I'd like to do here is just take out this small changeover on all of these baggers, flicking back to finish off this plain salted. So we've got a few options here. Let's just have a look and see what happens if we try and get the whole order just on the one bagger. So we can see here that that bag is too slow for the required volume. And what that's doing is then pushing this out here. We can see that the rest of the orders have done lunchtime on Thursday. We've got to wait almost another 24 hours before the fryer can change cut onto the crinkle cut. So one's obviously not going to cut it. What we can now do is remove that and put it onto 2 baggers. Recalling that the way to get it onto 2 baggers is with our forced routings table. So we'll just grab the SKU 1534 and I want to put it on P31 and P32. 1534. And let's do P31. P32. Okay. Move back here, rerun this, and let's see what happens. So we can see now that we've got 2 baggers running this product. They're not taking a small changeover in any of these, and we're still finishing well inside the time we need to get all these larger packs done. So the reason that a lot of these smaller bags are actually unutilized is just a design issue. Some of the other products have a much higher volume of small packs than large packs. So in order to ensure that the fryer is only ever running when large packs, is only ever feeding large packs as well as small packs, we've got to have a lot more capacity for small packs to get out that higher volume with limited large pack volume. In this case, we've got more than enough bagger capacity for these small packs compared to the large pack volume. Something else we could do is tidy this up. So let's not take so many changeovers. Let's just try and get the salt and vinegar, because it looks like a small order. Let's put the salt and vinegar all onto the one line here, Let's see what happens. Can we get the light and tangy onto another? Let's rerun that. No reason to pick the bag as I did. Let's see what happens. So we can see here that it's now pushing it out. So let's try and get this light and tangy onto 2 baggers. So that way I'll use the forced routings. I'm going to put them onto 26 and 27. So that's 1536. I'll delete that line there. I'll put 1536 on P26 and P27. So once that finishes, let's come down and we can see everything's fine. It's all inside the time it needs. Next part of the schedule to try and clean up, I won't do it in front of everyone and bore you all, but it's this bottom bit with all these extra changeovers down here. It looks like another situation where we could perhaps allocate 2 baggers to the light and tangy. Chicken's probably going to need 2 as well. Original might need 2, and then we'll see what Simio spits out for the last bit. I'll go and do that now and we'll come back to the results. So now we've cleaned that up a bit. We've still got some of these small runs towards the end trying to finish off these products. In reality, what we do here is just slightly adjust the demand so that it lines up. It's not really going to hurt anyone if we don't do the final 133 cartons. We can always catch up next week when it's not as bad of a problem. Also, when we actually get around to running this factory, it's not going to run at the planning rate. So really, let's just make everyone's life easier and trim this back a bit now. So what we can do to do that is just click on it. We've got a couple of options here. We've got an early finish, and we've also got a quantity here. So what we can do is we can actually set the early finish, and that'll force Simio to cut off at the time we put in here. We could have it line up. It looks nice if it lines up with the chicken, so we can grab that. So this one's finishing at 4:18 the afternoon. So we can just take this, copy that, and then pop that in here with the early finish. Well, can rerun that. And now it's looking a lot cleaner. So we can do this again if we want to. We could lose that little bit there, play with it more and more if we want. Really, it's not going to change a lot. So let's just leave it like that for now. Right, so that looks a lot different to what it originally did. A lot more efficient, fewer changeovers, a lot tidier. So really, not a bad plan. The next thing we might want to do is look at some downtime, or planned downtime. So what if a particular bag is going into service for a couple of days? So what we can do here, obviously this is going to cause a bit of an issue because we're already pretty under the pump to get all this volume out. Not ideal, we're running into Saturday afternoon. Anyway, let's see how bad it gets if we turn a bagger off. So the way I can do that, just stop that quickly. Open it out, and we've got this downtime, another exception, nice and easy, no different to any other Simio modeling, and we can just block out a time by dragging. So let's say that it's going to go night shift Tuesday into Wednesday. We're going to lose a chunk of time on that bagger. And then rerun that. We'll see what happens. So all that's done is pushed this out. We might want to use these shutdowns to improve the performance as well. So what we've got here is back up in cereal. We've got 2 fries. Now they're sharing baggers and seasoning drums, so it's a bit hard for them to fight for what assets they have available to them. What that does here is we've got this line graph showing the allocated bagging draw and the fryer output. So the golden rule was to never ever run the fryer short, but we can't slow it down. So we want this fryer always running close to its max output. You can see here, this long tail here is very inefficient for running. It's only putting out 180 kilos an hour when it should be 1100. We can't do anything with that gap, so effectively if we were to run this plan in the factory, we'd be losing, 80-something% of our product to waste as it goes stale. We obviously don't want that to happen. So something we can do here is actually block out the fryer until these other products on the second fryer have finished. Once they're out the way and the baggers are freed up, then we can go all out on this fryer with these products. We've got enough time in the week, so let's just have a go at that now. So I'll go into the downtime and exceptions. I'll just drag that out until this one's done. Fast forward and see what this looks like. So now we're getting a lot better. Our fryer output's pretty good. We're still dropping off as these larger packs fall away, and we're only left with 2 products to go. That's just part of the demand. We can do all sorts of things there, like staggering the baggers. So for example, we don't need to be drawing 1700 bagger at the moment. When the fryer can only do 1100, we could tone that down to 1400. Obviously it means we're running a much finer line if there are breakdowns, but that way we're trying to alleviate some of this problem out here. So we could shut down a couple of the baggers for the first bit. So let's say turn this one. Let's just try and take a bit of time out of that one. So this is the kind of easily manipulation that Simio lets us do here. And this way we don't have to keep going to an old static Excel, which couldn't even do these calculations in the first place. We have something dynamic, live in front of us, and we can easily see the impact of these things. So on this one, although it looks like it's not actually made any difference, because Simio's, well, I missed, and it started for a little bit of time, but that thing is still allocated to the bagger. It's just not having any actual output, and then the output picks up later on. You can see that although it's not made much of a difference, it still helped a little bit. So we've got 1100 here as the bagger draw. That's pretty, well, 1036, that's pretty close to our 1100. So we can slow the fryer down a little bit, that's not a problem. So the last thing we'll cover is some of the scenario modeling capability that we can do here in Simio. This is about those additional assets which aren't necessarily in the factory today, but there's questions around when would we need them based on volume growth or other factors. The one specifically we'll look at right now is this Hardbite 65 bagger. This would be a second twin head, and the reasoning for this one is as the small bag volume grows, and it's going to be growing faster than the large bag volume, there's going to come a point where we're going to need additional small bag capacity to be able to pack off all the small bags before the big bags are finished. You'll remember that from the fryer balancing, we can't have small bag baggers running on their own. So looking over at the results, we can see that currently, before making any changes, this is actually happening on this particular volume set. We've got a very small tail here of a couple of hours where just the small bag, this 28 gram bag, is actually running above or further than the 175 grams. Now we've got a few options here of what to do. We could trim the demand down a bit to line it up perfectly with that early finish thing we saw before. I could actually change the volume and just say we're not going to do 328. We're going to do 300 would probably do it. We could also turn off one of these baggers early. We could turn off H11 at 9 PM, say, okay, you're finished after this one. That would then extend these ones out and we wouldn't have that tail anymore. So we've got multiple different options, but we won't look at that right now. What is interesting is if the volume was a lot higher, that tail would be out all the way out here. And then suddenly that question around extending this run becomes a lot more expensive. We're adding new shifts on, we're potentially getting into Saturdays and Sundays, which we really don't want to be doing. So that's where the decision on how early do we need to buy this new bagger comes from. So in order to actually do this in Simio, on the asset master, we've got this capacity column. All the servers have capacity 1 if they're on, and 0 if they're off. So I've got the bagger that I care about at the bottom here with capacity 0. I'll turn that on, rerun the model, and see what happens. So we're not expecting the finish time of the large bags to change. As we can see, they're still here at midnight because all we're doing is changing a small bagger. What this has done though is brought the small bag finish time into early Wednesday morning. It's effectively halved it. We've got twice as much capacity now. So we can see how easy it is to answer these questions in Simio. And then all it is a matter of loading in more than 1 week of data into the demand. So we can load in a year, 3 years, whatever we want. We can click play, go and make a coffee, and come back, and we would be able to get the output logs and see how many weeks did this tail extend by with and without the second bagger. How long did it extend by? How many hours? We can have a cost per hour, and then we can actually analyze how many hours across the year did we have this tail, and therefore what the benefit of buying a second bagger would be. That's some of the work we did do. We're not at the stage yet of needing the second bagger, but we're not far away. So now we're done with running the model. Final thing I'll show you quickly is the output table. So this is one of them, the output schedule. This is just one line per order per bagger, what time it ended up starting on the bagger, when it finished on the bagger, what was scheduled, how many kilos were made, what description, seasoning and seasoning kilos. So this is around the seasoning requirements from the raw materials. That goes into the production dashboard, linked up to Power BI, so everything's visible to everyone in the factory. So that's the end of the Simio demonstration. I hope you've enjoyed it and can appreciate the power of having a dynamic scheduling model built in Simio. We can use it to answer lots of interesting questions, like when do we need particular assets, what the impact of a new bagger or a new fryer is, or even how much risk there is in turning a bagger off. The benefit of having it dynamic means that the schedulers have all the calculation done for them quickly. It can capture these complex interactions between baggers, seasoning, drums, shared assets like fryers and case packers that Excel just can't handle. You also see how easy it is to manipulate the plan. That frees up the scheduler's week for more interesting work, strategic planning decisions, looking further ahead around what the impact of these volume growths are going to be. So thanks again for your time and for joining me for this presentation.
Hello, Will.
Hey Drew, how you going?
How are you? I know it's quite late there in Australia, so appreciate you being here.
I think it's early now at this point. It's all right.
I was saying, I think if you can adjust your audio to be a little bit louder, a little bit.
How's this? Okay.
There we go. Excellent.
Just...
So I would say I think I can speak for all of the Eastern Standard Time attendees that leading this right into the lunch hour was good timing. So we've got a fair bit of questions to get into, so we'll take them on.
Easy.
So you mentioned a lot of the details. So how do you determine which constraints need to be more critically considered than others for producing the final schedule?
So this one I'd say there's no real golden rule there. This is probably where the human touch is more important for it. Probably a good rule of thumb would be minimize the chance of large negative events to the site. So we know that we can't slow the fryers down and stop them. You know, they lose and have the potential to lose millions of dollars a year from that. So it's a lot better to take an additional changeover on a bagger, leave a bagger vacant for a while. It might be a small waste of labor, but you really want to be maximizing your fryer output. So all the constraints to do with fryer changeovers, that kind of stuff is definitely where you'd look first.
Got it. Yeah, I'll say seeing that selection condition, there's obviously a lot that is being considered. So trying to determine one over the other is probably not the most straightforward of tasks. But let's continue along. So what is just the overall cadence for how often this model is being run?
Really depends on how well the site's running, to be honest. There's the capability in there, it's linked into the ERP. So at any point during the week, we can pick up the model, have a snapshot taken of what the factory's running at, what product's on every single bagger, how far through the orders are we, and we can rerun from that minute. So in general, we'd be planning, run the model a few times the week before to finalize the plan, lock the plan in, and then really you're only touching it in the week in the event that a catastrophic failure happens effectively.
Sure.
Really we're running it on a weekly for regular planning on a weekly cadence, and then the long-term scenario stuff is as and when required.
Yeah, so I think like you mentioned at the end, I think that's how you've built out the nice digital twin that is accommodating of a week aspect that you said you can also feed in a lot of volume to consider long-term goals as well. So, like, really dynamic is pretty cool to see.
Yeah, there's really no limit to what we can put into the demand file, really.
Understood. Yeah. Well, let's see what we got. So, yeah, you showed a lot of the great interaction that you can have with the Gantt. Is that common that you'd be manually adjusting the final schedule, or is that usually in the presence of unique conditions?
There's always going to be small tweaks. Simio is never going to come out with a perfect model, perfect plan, and week in week out with small volume changes, we see the impact of even just a tiny extra bit of volume of one product, and the plan doesn't look right because the model will flick it across all the bags at the
Mhm.
end, or there'll be a slight tail on one line. So we might be trimming those kind of things, but in general, the model creates a pretty good plan. It's 90% there, 95% there, straight off the
Yeah,
bat.
so that's probably where you lean on the expertise of the planners to know what is realistic, what is feasible. So probably a good interaction, I'm sure, between both of reducing a lot of their work, but then they can still have that expertise to put the final touch on things.
Yeah, exactly.
Next question. So, what was the overall experience like training the planners to use Simio relative to other planning or scheduling tools out there?
Pretty steep learning curve for them. So previously they were just planning in Excel. Um, the ERP suggests when to make things, but it's no more than that. So actually allocating products to baggers, all that kind of stuff was all done in Excel, very, very manual. So yeah, steep learning curve. We spent a lot of time with them, training them, basically taking them from day one of Simio all the way up to now they come back to us with model, like larger model changes and requests. But everything else they run themselves. They can run scenarios themselves. Um, yeah, they're very, say, capable themselves of running it. But yeah, it was probably a 3 or 4 month sitting alongside them, uh, getting them up to speed with Simio.
Yeah, I'm sure any change management to that extent is that's going to be a part of that. So I think probably, like you said, having that regular touch point is probably just a major benefit there to ensure that they're getting that buy-in.
Yeah, we could have rushed it, but I think when we rolled this out a couple of years ago, we wouldn't see the same impact we're still seeing today if we did rush it. So we made sure everyone's got a really good foundation and knowledge of what Simio is doing, how it's working, and that way, even if there is a problem, usually they're coming to us with, "I've already tried X, Y, Z." Um,
Mhm.
so it was definitely a long process, but worth it.
Yeah, so I'm sure that the less that it is viewed like a black box from their lens, and they more so understanding where things are coming from, that probably it's probably a little bit longer to get them in a situation like that. But like you said, you're probably saving a lot of time on the back end of not having to re-educate and go through that each and every time that they need to make a small change. So
Yeah, I think, and even on that, it's probably more important that they actually trust the model as well. So, and they understand it. So, yes, we want to save everyone time, but if we're not taking them along the journey of rolling out, teaching them the tool and all that, then are they going to really trust the plan that it creates?
right,
So,
right. If they
that
don't
is
have that
another
buy-in, then they probably revert to old hat, and next thing you know, the Excel
exactly.
is back in the fold. So, but let's see what question we have next. And I think kind of right along that point, so how do you determine the proper amount of touch points you want to give your end customers access to?
So I think that one really came down to how advanced they are at using Simio. Um, so they learned really quickly. They got a lot of control over them. Well, they had a lot of capability to control the model, so we gave them that flexibility. Um, we saw with how to manipulate what baggers different products go onto. There are different ways to handle different cases, and we had to have all of those options available. So it was really a matter of what are all the likely ways of having to manipulate the plan, and then how can we minimize the number of different touch points in Simio to achieve that. But in the end of the day, they have to be able to manipulate the plan. If they can't do one thing that they really want to do, they'll revert back to Excel. So we almost have to give them almost all control, and then.
Mm-hmm. Yeah, I'll say it's probably like you said, covering that 90%, but there's still going to need to be that expertise at the end of the day with knowing those factors that are very difficult to fully model out. That is each and every time considered properly. So I know we got a few more minutes and a few more questions. We'll proceed ahead. So, pertaining to the Gantt charts, are there additional insights or interactions that the user could have had that would have been valuable for your work?
So we've got it linked into the production dashboard. So there's a lot of analysis and metrics that happen over on the Power BI side there as well. Obviously, that's an extra step of running the model and then looking into a Power BI. I think overall, the Gantt chart and then those little line graphs on it showing what the fryers are doing are probably the most critical things. But we have done work previously on looking at the balance between your different cut types. That's something that we generally sit inside Excel when we're choosing what products to actually make for the week. If that would be inside Simio, great, but in the end of the day, the model starts with an Excel file. We've got the preliminary analysis in Excel. But yeah, definitely that probably volume mix analysis is the most useful.
Yeah, that makes sense. Let's see, a couple more here. So, what KPIs are you reviewing to determine the quality of the schedule produced?
Effectively, that's going to be fryer linked to the fryer output. So, are your fryers running short, or are they fully utilized the whole time? And then also looking at the kind of planned downtime that's coming as a result of the plan. So all the changeovers, see, a non-optimal plan is going to have a lot more changeovers. So we'd be tracking the projected number of changeover hours or cleaning hours along with your projected fryer output. And then there was that overdraw factor as well, which is effectively your safety. So if one bagger goes down, you want to make sure that you've got enough capacity on the other baggers which are running so that your fryer doesn't stop or have to run short. So that overdraw is another KPI that we care about, making sure that it's not too low, but not too high, because then you've got a lot of baggers sitting there only running at 20, 30% efficiency.
Sure. Yeah, that all makes sense. I think we got time for 2 or 3 more. But you mentioned adding in that greenfield site, and in addition to the 2 sites, were there any particular challenges related to the data when moving production to consider that 3rd site?
I don't think I've ever done a model that hasn't had data challenges. I think everyone on the call probably has experienced that.
Yes.
I think we had the benefit of the main source of everyone's data headache is usually your ERP and your master data. That remained the same. We used the same system. We just turned a new site on. So that really helped there. The new site we've been through multiple Simio models of that site as well. Worked with the client for a long time on the site capacity and planning, the greenfield site design. So when it came around to actually transitioning over and going live with a new site, we'd kind of already seen all the challenges we might experience. So we're pleasantly surprised that there wasn't that much head scratching going on.
I'll say I think if you don't have any battle scars from data, then you just haven't been through it quite yet, or that'll come at some point. So it finds a way to get everyone at some point. Let's see here, another question. And I think this may be the last one here. So are there critical assets, and you may have mentioned a little bit about the fryers, but are there critical assets in the model that you had to prioritize scheduling around?
There's a couple of really intricate ones. So I didn't show in the model, but there's a particular type of cut, the fries, where the volume of small bags is just so high that they need to use other baggers across the factory in other streams to bag this product. That has a really big impact on the rest of the site. So normally all the streams are independent. So all we need to look at is inside the stream, is the fryer being used enough? And do the baggers make sense, really? When we start talking about this extra product and some of these assets which are shared between streams, they're the ones which have the impact to, or the ability to impact the wider site. They're the ones that we really prioritize first.
Makes sense. Makes sense.
So,
Yeah, I'm sure with the product mix and the different considerations, there's probably going to be things that have those unique constraints to them that you have to work around. So that all makes sense. Well, Will, I think we are just about out of time. I want to, on behalf of Simio, I want to thank you for the presentation. I think really is from a modeler to a modeler, that was really great to see, and I'm sure that the rest of the community will echo the sentiment. But appreciate the time, and certainly look forward to further discussions.
Thanks a lot for having me.
Absolutely, and I know what I'm having for lunch, so that'll work well.
I might have that for breakfast.
Awesome. Yep, 3 meals a day.
Alrighty,
All right,
see you guys.
Care.